Okay, we're going to learn about asymptotes today. This is a good lesson. What are the x and y intercepts of the graph? So um, let's just find the x and y intercepts for this one first. So to find the x-intercept, you want to plug in y equals 0. So in this case, that would be 0 equals 1 over x. Multiply both sides by x. That cancels. X times 0 is 0, 0 x 1. It doesn't look like there are any x-intercepts in this one. Plug in x equals 0 to find the y-intercept. So that would be y equals 1 over 0, which is undefined. It doesn't look like there's any y-intercept. So this graph somehow doesn't cross any of the axes. It doesn't cross the x or y axis. And the reason for that is because those happen to be what are called asymptotes. And so an asymptote is a dotted vertical line. So you can hardly see it, but it's dotted. It doesn't, same thing here. There's an asymptote. Vertical asymptotes, this would be x equals 0. As a horizontal asymptote, so this would be y equals 0. Those are asymptotes. And so the graph is actually going to approach those lines, but never touch them. They're going to get really close to that line, but never actually touch it. So let's actually just plot some points. This is kind of like a parent graph of rational functions. Rational functions means it's a fraction. You notice this function is a fraction, 1 over x. And so when you have fractions or rational functions, you're trying to graph, typically there's going to be some asymptotes. So doesn't mean the x and y intercepts won't, oftentimes they have x and y intercepts, but they're usually going to have some asymptotes. And so we'll talk about how to find those in a minute. First, let's just go old school and just plot some points here. So we've already plugged in 0. That doesn't work. But let's plug in some positive negative numbers. So maybe like, let's do -4, -2, -1, 1, 2, and 4. Just plug in some different values here. So if I plug in 1, 1 over 1 is equal to 1. So I'm just going to kind of put some tick marks here. Okay, so 1, 1 is a point in this graph, so it goes through that point. If I plug in 2 here, that'd be 1 over 2, which is 1/2. So 2 comma 1/2 is right about here-ish. This would be 1 over 4, so 4 comma 1/4, right about, getting closer to that line. I think we need to plug in a couple more points. So let's plug in 1/2. This is going to be kind of weird, but let's see what happens. This would be 1 divided by 1/2. Divided by a fraction, you multiply by its reciprocal. So that's 1 times 2, or 2. So 1/2 comma 2. So right up here, somewhere in this neighborhood. If I plugged in 1/4, similarly, that would be 1 divided by 1/4, which multiplied by the reciprocal is equal to 4. So 1/4 comma 4, somewhere up here. You see this graph is kind of approaching both axes. It's getting really close, but never touching those dotted horizontal and vertical lines there. So that's the right-hand side of this graph. If I plug in the left-hand part here, so this would be 1 over -1, which is -1. So -1, -1. This would be 1 over -2, which is -1/2. So -2, -1/2 is right about here. 1 over -4. So somewhere right in here. If you plugged in for x, if you plugged in, say, -1/2, be 1 over -1/2, which is actually -2. So 1/2 -2 is right about there. And if you plug in 1/4, it'd be right in there. So you can see this graph on the other side is kind of doing a very similar thing. It's approaching both of the asymptotes, but never actually touching them. You get closer and closer, but never touching them. This is the parent graph. I kind of want you to know this graph. We'll get to problems where it'll help you to know. You just kind of know this graph. I don't need you to know every point. In other words, if I asked you to graph, this is what I might expect. You go, okay, I'm going to graph this. So I'm going to graph a dotted horizontal line at y equals 0. Always put the equation of the asymptotes, a dotted vertical asymptote at x equals 0. and the graph would look roughly like this. It'd be in the first and third quadrant. And that would be a good enough sketch of this graph. That's really what we're doing. We're sketching graphs, not plotting every point like this. So just more of a sketch than a perfect graph. But I do need to have the asymptotes labeled with the equations, always with the equations. And you should be able to tell which quadrants they're in, etc. If there's intercepts, I want to know what the x and y intercepts are. So general rule of thumb here, there's something called vertical asymptotes. That's what VA is. So first you want to sketch the vertical asymptotes and if there's any holes. We'll talk about that in a minute. Then you'll sketch the horizontal asymptotes. Again, always use the equations for those. So don't just draw a horizontal line, but it'd be y equals whatever. For a horizontal asymptote or vertical asymptote, it'd be x equals whatever. Intercepts, you want the x and y intercept, and then you might have to plot points. We'll talk about that last step when we get there. So first, let's talk about vertical asymptotes and holes. So let's do 4 graphs, and we're going to find the vertical asymptotes and the holes of the graph. So the way you find a vertical asymptote, so vertical asymptotes, you look at the denominator, and you find out when that denominator, if you think about, even the graph of 1 over x, so let's just graph that for a second. So if you have 1 divided by x, right, if you look at the table for that one, Control T, there's no value for 0. It says undefined right there, right? Because, and the reason it says undefined is you can't divide by 0, right? 1 divided by 0 is undefined. So on the graph, there's a vertical asymptote whenever x is 0 because it makes the denominator 0. So you're thinking to yourself, what value would make the denominator 0 here? That's going to be your vertical asymptote. So if you plugged in a 2 there, I mean, you could always just solve this x minus 2 equals 0 and solve it for x equals 2 is the vertical asymptote there. So that's your vertical asymptote at x equals 2. So if you have your graph, for this one, right away we know there's a vertical asymptote at x equals 2. So you would draw that first at x equals 2. Notice I used the equation for that. On this one, you look at the denominator. Again, we're just setting the denominator equal to 0. So x plus 1 equals 0. So x equals negative 1. That is your vertical asymptote. So when you graph this graph, your graph a dotted vertical line at x equals negative 1. So x equals negative 1. Always label the vertical asymptotes with the equation. Don't say negative 1 because I don't know if it's vertical or horizontal. If I say x equals negative 1, I know it's a vertical asymptote. We haven't gotten to holes yet, but let's continue our work with vertical asymptotes here. And so on this one, really before you do anything, I need you to factor that. The numerator doesn't really factor, but the denominator does. It factors a little bit more. Hopefully you see it. It's difference of squares there. So x plus 2 and x minus 2. So if you look at that denominator, now you see a couple of values that if they were 0 would cause problems in the graph, right? So there are 2 solutions or 2 vertical asymptotes. So there's a vertical asymptote at x equals positive 2 that comes from this factor, and there's one at x equals negative 2 as well. So there can be multiple, and that comes from this. So there can be multiple vertical and horizontal asymptotes here. So in this case, just kind of graph this out here for a second. So this is going to be at x equals negative 2. And x equals positive 2. Okay, and this last one, this is where the hole comes in. So if you've got it factored, which you do, you may notice something interesting about this problem. The x plus 1 cancels. So when that happens, so when you cancel with rational functions, you're going to cause a hole. And right away, you know the value of, normally you would think there's an asymptote at x equals -1, but there's going to be a hole at -1. But you have to figure out the y value. So to figure out the y value, the key to this one is to plug in x to find y, So once you know, normally there would have been an asymptote at x equals -1, but there's going to be a hole at -1. But find the ordered pair of the y value there. So plug in -1 and plug in x. Let me say this: after you cancel. That's going to be important. If you try to plug in before you cancel, it's not going to be very easy to do because you get undefined for the denominator, right? See, after you cancel, so now we just have x plus 2 over x minus 3. So there would be -1 plus 2 is 1 over -1 minus 3 is -4. So I get -1/4. So there's a tiny little pinprick, a hole in the graph at -1 comma -1/4. We'll get to that in just a minute. Let's go ahead and graph this out. So okay, so let's try to plot that point. So at -1, -1/4. So right about there. Oh wait, I drew that with an open circle. I should have driven that. So let me try to get that out of the way so you can see what I'm trying to draw here. So -1, -1/4. There's a little tiny hole in the graph at, so I drew kind of an open circle there at -1 comma -1/4. So that's going to be a hole in the graph. We'll get to that in just a minute as far as what it looks like when you actually graph it. And then it looks like there's also, I need another tick mark here. So when you do the vertical asymptote, so this one's going to cause a vertical asymptote at x equals 3 is the vertical asymptote there. So x equals 3, so dotted vertical line right here, and that's at x equals 3. Okay, so there are 3 cases for horizontal asymptotes. So now we've done the vertical asymptotes, we've done the holes on this graph. We still haven't sketched the actual graph yet. But let's talk about horizontal asymptotes. So with horizontal asymptotes, there are 3 cases. So let's talk about those 3 cases here. So this is the 3 cases that you might face. So the first thing with horizontal, you may have top heavy in degree. What I mean by that is for the fraction. So if you have like, you know, so y equals, just going to make up a function here. So let's say I have x squared on top and x in the denominator. And it doesn't really matter what's after this. The degree of the top is 2, the degree in the bottom is 1 there. So this is top heavy in degree. Therefore, when that's the case, so when it's top heavy, there's no horizontal asymptote. So when it's top heavy, there's no horizontal asymptote. That's going to happen. Some functions have a larger degree on top. You might have 2 factors on top and 1 on the bottom. So let's look at one that is bottom heavy. So in this case, you might have like x plus 1 in the numerator, x minus 1 times x plus 3 in the denominator. So this has a degree of 2 in the denominator, a degree of 1 in the numerator. And so when this is the case, when it's bottom heavy, there is always y equals 0. So it's like the x-axis is basically horizontal asymptote. And the third case, which is kind of an interesting case, is when it's same degree. So let's say you had something like y equals 4x squared plus 1 over 2x squared minus x. So the degree on top is the same. So when it's the same, there will be an asymptote, or a horizontal asymptote, at you divide the coefficients. So you divide the coefficients. So in this case, like 4 divided by 2. So this one would have 1 at y equals 2, or y equals 4 over 2. So whatever the leading, maybe I should say the lead coefficients, you're dividing the lead coefficients there. So I'm not worried about the coefficients of these guys, but the very first term, the ones that match, have the same degree, x squared, 4 over 2. There's going to be a horizontal asymptote at y equals 2. Again, don't just say 2, it's y equals 2 if it's horizontal. Okay, so let's think about what case this is. So we have x to the first on top, x to the second in the denominator, x to the first on top, x to the first on the bottom. So the coefficients are 1 and 1. So this is same degree, therefore there will be a ha at y equals 1 divided by 1, which is 1. So there's a horizontal asymptote right here at y equals 1. Let's find the horizontal asymptote for this one. So it's top heavy, so there is no ha. So I just don't have one. That's going to happen sometimes. This one is same degree, so you divide the leading coefficients, so there's a ha at y equals 3/2, which is 1.5. So right about here, y equals 3/2 or 1.5 there. And this one, same degree, top and bottom, so second degree on both. The coefficients are 1 and 1, so there's a ha at y equals 1. So there's a horizontal asymptote at y equals 1. Okay, the next step, so find the vertical asymptotes in the holes, find the horizontal asymptotes, is find the intercepts. Again, to find the y-intercept, plug in x equals 0. To find the x-intercept, plug in y equals 0. So we're going to plug in those values and see what we get here. So the intercepts would be, let's see. So for this one, the y-intercept, I like doing that one first, is plug in 0. So the y-intercept is going to be 0 plus 1, or 1, divided by 0 minus 2 is negative 2. So there's 1 at negative 1/2. So there's a y-intercept right there. It's helpful to know. And the x-intercepts, you plug in y equals 0. So this would be, so the x-intercept would be 0 equals x plus 1 over x minus 2. What happens here is when you multiply both sides by x minus 2, the x minus 2 goes away, and so you get 0 equals x plus 1. So the solution would be x equals negative 1. So there is one x-intercept only at negative 1. And by the way, I think we're kind of ready to draw this graph, to sketch out this graph. So the last step is to plot some points if you need it, but I don't think we really are going to need it on this one. So you can see these 2 points are, connected. There's going to be a graph there, and it's got to approach the asymptote. So this graph has to kind of approach the asymptote. It doesn't cross back over. It doesn't cross the x-axis again, so I know it doesn't go up there. It's got to go down and kind of approach the asymptote. It's kind of like a fence. It goes right up to the fence, but it doesn't touch the fence. Here again, the graph seems to be going through. It's going to approach this asymptote here at y equals 1. So the bottom left-hand portion of this graph is just going to look like that. By the way, there's no, if you look at this plus sign, even look back to this graph, there can't be a graph here and here. The reason for that is because those are vertical from each other. That's not a function. So I know, you'll never have, if you have kind of like asymptotes here and asymptotes here, on the left-hand side, maybe you'll have it here or here, but not both. The right-hand side, maybe you have it here or here, but not both. It can't be both because that doesn't make a function vertically. So going to this one, top left-hand side, there's nothing because it wouldn't be a function. The graph on the top, on the right of the x equals 2 asymptote either looks like this or like this. Those are my 2 options. But I think I know without even graphing it that it can't be this one. The reason it can't be this one is if for this one, it would have to cross the x-axis somewhere over here, I don't know, 3 or 4 or something. And it doesn't. It doesn't have an x-intercept. We already found the x-intercepts. And there was just an x-intercept there. So the graph on the right really does have to look like this. And you're done, right? That's the sketch of this graph. If you were to graph that in your calculator, quite sure we would be pretty close to the real thing there. Let's see. So If we do control divide x plus 1 over x minus 2, and that's what it looks like, right? That's the graph of that function. And to not have a calculator and graph that, it's a pretty impressive little sketch we got there. Okay, so for this one, we've got to find the intercepts, right? So the intercept should help us a bunch on this one. We'll see what happens. So plug in to find the y-intercept, plug in x equals 0. So if x is 0, this would be y equals, I guess it would be 2 times negative 3 divided by 1, which is negative 6. So, oh wow. So I'm going to try to make these tick marks a lot smaller. So 1, 2, 3, 4, 5, 6. That's just what it has to be here, so it can kind of fit. And I have a y-intercept at negative 6. And let's see, let's plug in the x equals, or y equals 0. So this would be to find the x-intercept, y equals 0. So that would be 0 equals, again, we don't really need the denominator because it's going to go away. So x plus 2 times x minus 3. And that's really already set up for us. The solution would be x equals negative 2 and x equals 3. So solution at negative 2 and positive 3. So on the right-hand side, I think I kind of know what this graph's looking like. It looks like it's got to approach the asymptote down there, so it's going to go kind of up and to the right. I'm not sure exactly what it does, but on the bottom there, it's going to approach that asymptote. On the left-hand side, here's the thing I don't know. I know it approaches the asymptote. It either kind of does this or does this, right? Those are the only two real possibilities here. I don't know which one it's going to do, so this is a case where I really need to plot another point. Don't plug in negative 1 because that's asymptote. Don't plug in negative 2 because we already know that. Let's plug in negative 3. So if you plug in negative 3, let's see what happens. So if we plug in negative 3 right here, and negative 3 right here, and negative 3 right here, let's see what we get. We get negative 1 times negative 6 over negative 2. So that's really 6 over negative 2, which is negative 3. So when I plugged in negative 3, I got negative 3, so somewhere down here. So now I know my graph is going to go up and approach the asymptote. It's going to connect those 2 points. It's going to continue that pattern. So the graph looks something like that. Those are probably the toughest ones to do just because it really helps to have a horizontal asymptote. It helps our sketch to be a lot better, actually. So this one, let's find the intercepts here. So plug in x equals 0 to find the y-intercept. So that would be negative 4 in the numerator divided by 2 times 2 is 4 times negative 2 is negative 8, which is positive 1/2. So right about here. And then let's find the x-intercepts. Again, to do that, don't worry about the denominator. Let me get rid of this just so I can have some room here. So set the denominator equals 0, so 0, or the numerator equals 0, 3x squared minus 4. So 4 equals 3x squared divided by 3. The square root x equals the square root of 4/3. Actually, though, it'd be plus or minus because you have to take the square root of both sides. So square root of 1 1/3, square root of 4/3. Boy, you have to get your calculator out to kind of simplify that if you want to get approximation. So square root of 4/3 is 1.15. So plus or minus 1.15 are the x-intercepts. So right about here-ish. Right about here. Remember, this is only a sketch. Okay, I kind of know what's going to happen here. So it looks like it's going to connect there. It's got to approach the asymptotes. So in the middle, it's looking kind of like a U. That kind of makes sense. On the right and left, so to the right of the blue asymptote there, it either is going to look like this or like this, and hopefully you see it. If it was this, it would cross the x-axis. It does not cross the x-axis there, so it's got to be that. On the left-hand side, it's either going to be here or here because it really doesn't cross the x-axis again. It's got to be this top one. So that's what your sketch of the graph is going to look like. And on this one, let's see, plug in x equals 0. We can do it after we cancel. That's fine. So this would be, the y-intercept would be 2 over -3, which is -2/3, which is right about here. And if you plug in x equals 0 or y equals 0, the denominator goes away. You're going to have 0 equals x plus 2 times x plus 1. So solutions are x equals -1. These are my x-intercepts, and x equals -2. So -2 and -1. Oh, that's weird. -2 and -1. Very strange. Okay, so on this one,